So this is our project 1 for lighting an LED with a 9-volt battery. So first I have our diagram which illustrates our energy source, which is a 9-volt battery. And you have the positive and negative ports, and then it goes towards the resistor, which is a 470 ohm resistor that feeds into a red LED. And as you can see here, it took some troubleshooting, but we were able to make the LED light up.
The numbers if you want.
So you can see we have the 9-volt battery here. That's the power source, and it feeds into the breadboard and into the resistor, which into the resistor that goes into the LED and reports it back to the negative side of the breadboard.
It's just what we did these 2 times.
So we measured. So we're going to measure the resistance of the current. Ohms. We're just going to disconnect the battery.
I would think that her resistor we still have.
We're just measuring across the LED. That's what he was asking.
Okay, that makes sense.
And then show the LED lights when you connect power either to the board or to the other end.
But how does that affect the voltage?
Alright.
Oh wait, current. So we have ohms and we have
So the average is about 0.6 ohms.
voltage equals current times.
And so now we're going to check the current by plugging in the battery again.
If we divide 5 by
If you want to do the
And making
do this
sure that
step, and
the
then you want
leads
to
are
talk,
actually
you want
in.
You should probably
talk, and then
out of it. I'm
Now
sorry.
we are going to check the current by
And then you can just
putting
unplug
the
this and
2
plug it back in
ends.
to show that
First of
it's
all, we need to put it to MA.
across resistor.
And
we
we're going
decided to go with
test
the
the
220
LED.
ohm
In order to
resistor,
flickering as the
and
current is
we measured
disrupted.
2.37 volts across the LED, and we believe 11 milliamps are flowing, but we did not completely check with the DMM. And then this is it working.
So it also averages about between 5 and 6 milliamps. And
Hard to say, but we did not check.
that is
Because it
our
doesn't tell us to
project.
check.
So this is our project number 2, which is lighting an LED with the 5-volt, using the 5-volt Arduino board instead of the 9-volt battery. So we have the exact same setup, except instead of using the battery as our power source, using the Arduino board, using a 9-volt plug.
Kellen,
And
did you blow up my red LED?
The same, it has the same power. It's using a 5-volt power input this time instead of the 9-volt. And according to calculate, we use a 470 ohm resistor just like
You just
before.
put it in the wrong hole.
And we found for the voltage change across the resistor was 3.025 volts. The voltage change across LED was around 1.9 volts. And adding them together is around 5 volts rounded up, so it makes sense. And then I changed the order of the LEDs. I changed the order of LED from the positive to negative, and changed the orientation of the resistor as well. And for the voltage change across the resistor, I may have done it wrong, but I got a value of 0.01 volts on average. But for the voltage change across the LED, it rounded off to around 4.9 to 5 volts. And you can see that the LED light is shining bright. Although when you move it to from 5 volts to 3.3 volts, the LED is still on, but it is dimmer because of decreased
each one goes with
current.
their own one.
But if you move it back,
Their own bus.
you can see it's brighter. You move it back to 3.4 or 3.3. You can see how it has been dimmed. So that is our project. Okay, so this is project 3, switching a basic circuit. So, and like the first 2 projects, what we did is we were trying to power multiple LEDs. Trying to power multiple LEDs through using their own switch. Instead of all of them going through the one power source and running continuously, each is going to have their own switch. So species 3C. So we started with 5A, which is powering one single switch, which is the red one. as it goes, the power goes through the wire into the switch, into the circuit, the 220 ohm circuit, into the red LED that goes back to ground. And then 2, we did the same with the yellow one. Although since it goes to the 220 ohm resistor once, the power output is less. It causes it to be dimmer. And for 3C, we did a circuit series where in order to power all 3, we had to connect the third button to the original power source on the positive side. So the power feeds through the cord into the switch, into another 220 ohm resistor, into the green, which is then grounded back into the negative side, which causes it to be as bright as no power is lost, unlike the yellow one. So that is, and then we have the schematic drawings where we have the power source and the three buttons and the LEDs that all go back to ground. That is our project.